Hello, everybody. Today we will start with resonance. And as you know, resonance plays a big role in many fundamental ideas, not only in your 11th standard, but even in your 12th standard. So, I have come up with uh, a, a dual mode of teaching. And I will do some scribbling in the board, which you can definitely connect it with a clay model, which you can replicate and go ahead with the studies, because this topic is required on and off and on, in so many different uh, topics in 11th and also in 12th. So let us start, and I hope you like my new idea, and hope you definitely understand this topic better along with the clay model. So let us start. We will start with positive resonance today. All right, but before we start with positive resonance, let me tell you what exactly is resonance. So this is benzene, and I fix the positions of the carbon nucleus by putting numbers on them. Okay, and if you see the next structure which I am drawing, its bonds are inverted, but the carbon positions are same. You cannot tell me, ma'am, both these structures are similar. No, they are resonance structures of each other. You can see the double-headed arrow indicating that they are interconvertible. So the nucleus of carbon is fixed, and what happens is the delocalization of electrons. See, with the help of the arrows, I've shown how the electrons are getting delocalized. Delocalized means moved from this position to this position. So when the pi bond, which is the weak bond, moves from position 1, 6 to position 1, 2. See, this is, you can think as the action structure, and this is the reaction structure. So similarly, the bond between 2 and 3 is now shifted between 3 and 4, and the bond between 4 and 5 carbon is shifted between 5 and 6. So this is about resonance. All right. And if you ask me which of these structures, 1 or 2, represent the true structure of benzene, the answer is neither. We have something called a resonance hybrid, which is a combination of both the structures with partial bonds between all the carbon positions. So the bond order between all the carbons is 1.5 or 1.5, shown by a permanent bond and a delocalized bond, which is giving half a bond. Right? So this is about resonance. So let's proceed to positive resonance with an example. So today's video will only deal with positive resonance, and in my subsequent videos I'll come up with negative resonance also. So in positive resonance I'll take up aniline. अरे aniline जानते हो ना? Aminobenzene, वो है aniline, aminobenzene. Okay, so let us start the positive resonance, and what I will do is that involve the lone pair of nitrogen in the resonance. Okay, so that is about positive resonance. Lone pair, where the lone pair of nitrogen is also getting involved with the pi cloud of benzene. Okay, so this is NH2 aminobenzene, and this is the lone pair. So this is getting involved in the resonance. See, the pi, the electrons is becoming a pair and is taking up a pi electron character. All right, it's the lone pair is taking a pi electron character. So naturally the carbon 1 is becoming pentavalent. So this pi cloud is coming here, all right, in the carbon 2 and becoming negatively charged. This carbon has a lone pair. So it's like behaving like a carb anion. All right. So this is the lone pair. Next, this and this, we have not done anything to it. So let us proceed to the next structure, from structure 1 to structure 2. This is where the lone pair has become, this is carbon 1, okay, don't mistake it. So the lone pair became a pi bond, and the pi bond became a pair of electrons. Let us go to the next structure, where we don't look at structure 1 anymore. We look only to structure 2. So this pair of electrons comes in, and subsequently, for the same reason as before, the pi bond comes to this carbon and becomes a carbon ion, and this pair of electrons becomes a pi bond. Okay, nothing happens to this. Wherever we have not touched the rest of the double bonds, it remains intact. Understand? Okay. Going on to the next structure, this is structure 3. We do not look at structure 1 and 2 anymore to draw a fourth resonating structure. Once again, this bond comes in, becomes a paired pi bond here, and this comes out. This becomes a carbonyl. So where do we have the carbonyl? Let us see, this is 1, 2, 3. The carbonyl is on carbon 4. So on carbon 4, there is no carbonyl anymore. Let's number it, 5, 6. We have the carbonyl on position 6. Remember to replicate the structure exactly wherever you have not done anything. So now we have the final structure where this becomes a pi bond, and final structure has a pi, and another pi. And the lone pair comes back on nitrogen. So if you look at structure 5 and structure 1, the bonds are inverted with respect to each other. So this is about the electron on nitrogen undergoing resonance or delocalization along with a pi cloud of nitrogen, and assuming a structure with the double bonds inverted with respect to each other, if you see 1 and 4. Now let us draw the resonance hybrid, the actual structure of aniline. So this is a dashed bond indicating the partial double bond character of all the bonds wherever the electrons have delocalized. Now see, I have drawn this where the lone pair comes here. Come on, get your clay model and try to replicate with me. What happens? What happens? The lone pair is coming here and this pi bond breaking and forming a pair of electrons. Pause my video. Have you paused your video? Can we go over to the next structure? Get your clay model, get working. Keep a notebook by your side so that you can, the moment you're moving the electrons in 3D, you are actually trying to understand what is happening. So get your notebook, get started. See the second structure, it moves in. So it forms a pi bond here. And then the bond comes out. And that is where you get a carbanion at the para position. So the ortho position has a negative charge in structure 2. In structure 3, the para position has a negative charge. So isn't it getting interesting? Aren't you understanding? The pi electrons from the para position comes in, and again the ortho position in structure 4 becomes negatively charged. So we have reached the fourth structure, and from the fourth structure to the last structure, see, you have achieved something. You have learned it in a 3D way, and it's so interesting to see the electrons moving around benzene, isn't it? You would agree with me? Put a thumbs up, please. Do not forget to put a thumbs up. Okay, come on. And a pair of electrons from the ortho position comes in, and the pi bond breaks and creates a pair of electrons back on nitrogen. We have reached a final structure. And resonance or the delocalization of electrons, which you have localized the electrons with your hand itself around benzene and around nitrogen. Oh, you have learned it. You have learned resonance. Hope you liked the video. And this is about positive resonance. Why positive resonance? Because the lone pair which is there on the atom attached to benzene, the lone pair, if that also plays a role in getting delocalized and creating negative charges at the carbon positions, that is about positive resonance. Okay, thank you very much. And if you have liked this video, do not forget to subscribe and of course put a thumbs up on the like button. Thank you so much.